Dealing with your own data always comes with challenges, but V7 is here to assist you with all your data management needs. It's always possible to import data to V7 from the UI and command line interface. But did you know you can also programmatically upload files to V7 using the REST API as part of your data pipeline? Oh, and there's of course no need for data privacy concerns. V7 also enables you to register files from an external storage bucket if your data is, for example, stored in an AWS S3, GCP or Azure Blob Storage. This will enable you to annotate your data without it ever leaving your own storage bucket. But first, let's have a look at how to upload your data using the UI. Okay, let's start by creating a new dataset, which is really simple. We'll go ahead and click on this new dataset button. And the first thing that we need to do is provide a name. And let's call our dataset cats. Now if we continue, we can see that we have the option to click to upload or drag and drop some images in any of our supported file formats. Or we already have here the command line interface commands that we'll get to in a second, ready to copy and paste. So let's first go ahead and drag in those 3 images of those pretty cats, and then continue. We can here already create new classes for our dataset, but for now, let's just skip that. And we can now connect a new workflow, either one of those that you've already created, or just a new one, a new basic workflow. And here in this dataset view, we can already see that all 3 images have been uploaded. We can click on one of the images and start with the annotation process, but this is not the focus of this video. Now, I've already teased it, but another very simple method of uploading data to V7 is using the command line interface. To do so, we use the Darwin dataset push command. We then specify to which team and dataset we want to upload the data, and we provide the path to the locally stored data. The optional path argument can be used to upload files into a specified directory. But if you want to just copy over your own directory structure, you can add a p argument to your command, and you will see the folders mirrored within the dataset in V7. When dealing with videos, you can optionally specify the extraction rate by adding the FPS argument. When leaving this argument out, you would use the intrinsic frame rate of the video. Finally, to indicate file extensions that are to be ignored from being uploaded, you can use the optional exclude argument. Okay, that was easy, but we can also upload images from our local storage using the REST API. Okay, let's look at the code and start with the imports. Since we're using the REST API, the only import that we really need is the requests library. I also import my API key, which is stored in a separate file, so I just don't have to show you what my API key is. Okay, then let's get to step 0. Which data do we actually want to register or upload? Right? I here just manually specify the paths to the 2 images that I want to upload, that you can of course loop over your whole directory and collect the paths that way. I then also create a dictionary with the file names as the key and the file paths as the value to just easier iterate over the images and automate the whole uploading process. In the end, I will have this little dictionary right here, which has again the name as the key and the path as the value. Okay, now we can get to the actual step 1. We need to register the data to V7. We need to tell V7 how many images we want to upload and what their names are. So for that, let's construct our message that we want to send using a post request. So the first thing that we need to specify is of course the URL. And for that, you'll always have the same URL, but you always need to provide the team slug, the slugified team name and the slugified dataset name. If you're not familiar with the term slugified, then I'll have a link in the description where you can look at the documentation and everything should be clear. So after plugging in the team slug into the URL, we can get to constructing the actual payload of the message. So therefore, we can now iterate over all the items. That's why I've created this nice little dictionary. We then append a list with the following messages or information. We'll have the slots key, and we'll here pretty much only need to provide the file name, and we'll then again have to provide the file name a second time. This list of all slots will then be added to the payload in the items key, and in the payload itself we also only need to provide the dataset slug to just know which dataset we want to upload our items to. The payload will pretty much always be the same, right? We want to specify what type of data we accept as a response, with what type of data we are working with, and of course the API key for authorization. After that is done, we can post our payload to the URL, including the header. And if we look at the response, we can see that we have a list of all items. All items have a specific ID. We can see the name. And most importantly, we can see that we have a upload ID for each item. And this is important because this is our registration ID that we will then use to sign our upload, to actually upload the data and then confirm it. So from this response, we want to extract those upload IDs, and this is what we are doing in this little loop right here. So let me quickly just execute this cell, and you know what? Let's just go ahead and also look at this dictionary, and we can see that we have our upload ID as the key corresponding to one certain path. And now we can get to steps 2, 3, and 4, which are pretty much things that you need to do for every single image or item that you want to upload. Okay, let's have a look at what this is. So for every upload ID, right, we have now registered our data. V7 knows which items we want to upload, or what they are called and how many. And now we need to actually sign the upload and store the upload URL to then actually upload the data or the file using this URL for the specific item. And after this one specific item has been uploaded, we need to confirm this one upload. And this needs to be done for every single item. That's why we loop over all of those upload IDs, which are again necessary or corresponding to one specific item. Okay, that might have been a bit fast, so let's have a look at the code in a bit more detail. Step number 2. We first need to actually sign our upload. So what we have now again done is we have registered that we want to upload 2 files, right? And we have received a specific upload ID for every single file. Now we want to sign this one item using this upload ID, right? We are going item by item. And then with the response that we get, we want to extract the actual upload URL. So we are signing one item that we have registered, and we have got the permission to actually upload the data to this specific URL, which we are going to extract. In step 3, we are actually going to read this one file, this one image, and then upload it using the URL that we have been assigned to, that this image has been assigned to. So this is one simple put request to the URL, and the data is again the image. And with this response, we will just have a look when uploading it, and we're then pretty much already done. We now simply need to confirm the upload, where we again just have one specific URL that we need to send a message towards, which again needs our Sluggified team name, and again the upload ID, right? We want to see if this one specific upload or this one image with the corresponding upload ID has been uploaded successfully. And this is really important, you need to do that. We can see that all the responses were successful, and let's actually see in the UI if we have successfully uploaded our data. And here it is. Cat 4 and Cat 5 have been successfully uploaded. Now that's already pretty cool, but you can also use V7's slots feature to upload multiple images or files into one item. The most common use case that we see this feature used for is mammography hanging protocols. But slots can be used to display any pair or group of files on screen at once. For more information on that, please refer to the documentation. That wasn't too bad, was it? But if you're dealing with sensitive data, uploading those images to V7 might not be an option for you. That's why we offer you a solution to connect your external storage bucket and register the images to V7 so that Darwin simply knows where to access the images in your own external storage. That means your data never leaves your trustworthy storage. So let's have a look at how you can do exactly that. Register your bucket and your files. Okay, let's start with the first step of registering your data from external storage. Configuring the storage bucket. And doing that is really simple. We first need to go to our settings and then click on our storage tab. We can here now add a new storage integration. We then again need to select the provider. In this case, let's just go with AWS S3, and we can select a name for our storage bucket. This is the name that we can define ourselves that is then used in V7 itself. The actual S3 bucket name is then provided right here. Optionally, you can also provide the prefix to the data. For example, when your images or files are stored in a certain directory in your bucket. We then, of course, also specify the region that we are in. Let's say we are in EU North, and then we can specify if we only want to have read-only access, and that's it. We can save our configuration. After the external bucket is ready and you have populated it with images, you need to notify Darwin which images you want to list and for which dataset they are. This is done via a REST put request. If we look at the code for registering files from your external bucket, the code is pretty similar to the just discussed code for uploading images to V7 from local storage. We again need to authenticate ourselves using our API key, and we need to provide our team and dataset names. This time we also need our storage bucket name. Our header section is again the same. In the payload, we now list all items that we want to register. The path argument tells us in what directory V7 will display the items in the UI. The name argument is the name of the file that you want to register from your storage, including its extension. The asFrames argument is a Boolean value denoting whether you want a video to be registered as a video or as frames. We here provide the name of the slot. We have a whole separate video on slots, so feel free to look at that or read the documentations. But if you only have one item in an image, then you can just enter this value as 0. The storage key is the path to your file in your storage container. For example, you have a folder called car folder, and there you have one image called cars. The file name is the name of the file in a particular slot. Note that this will only be relevant to those with multi-slotted items, such as hanging dicoms. Of course, we again need to add which dataset we want to register the files to. And we also need to provide the name of the bucket we want to be using. And that's it. You can of course add more files in the same structure to this list of items. And you can of course automatically generate the payload with multiple items by looping through all items in your own directory and appending them to the list given the just discussed syntax. Now, dealing with videos and read-only access storage is handled very similarly, just with tiny tweaks. Feel free to look at the documentation. After watching this video, you should be equipped with the most important skills. And now we're actually done. You now know how to upload your own locally stored data to V7 using the UI, command line interface, and also using the REST API. If you don't want your data to leave your storage buckets, you now also know how to register this data, again using the REST API. Okay, I hope this video helped you with getting started with V7.